Okay, we're going to take notes on the last lesson in Chapter 9. When you're taking notes on this video, you take them the same way that you take them in class. You're going to start by writing down the title of this section, 9.8, the sine and cosine ratio. If I'm going too fast on the video, it's important that you stop it and catch up. Don't let me move on without you understanding how to do something. It's also okay if you go back and we rewatch something because you missed something. Today's goal is to find missing side lengths of right triangles. You do not have to write that part down. We've learned how to find missing side lengths of right triangles through the Pythagorean theorem. There are two special right triangles, our 45-45 90-degree triangle and 30-60 90-degree triangle. And then the last lesson we learned how to find a missing side length with the tangent ratio. There are two more ratios that you need that give you different information than what the tangent ratio uses. After you have the title written down, go ahead and draw this triangle. Push pause. We're going to use this triangle to find the ratios for sine and cosine. Let's start with sine. The sine ratio is opposite over hypotenuse. So let's use angle A. To find that ratio, I'm going to look at angle A, and I'm going to find the side length that's opposite, y, and put it over the sine length of the hypotenuse. The hypotenuse is always the longest side length, so z. And then cosine is the ratio adjacent over hypotenuse. So again, using angle A, I'm going to find the adjacent side, that's x. Technically, there are two adjacent side lengths. Adjacent means next to. One is going to be a leg, one is going to be the hypotenuse. Adjacent refers to the leg, and the hypotenuse is always the longest side. Now that we have three different ratios, we have tangent from the last lesson, sine and cosine, you're going to need a way to help you remember the three ratios. And that is the phrase Sohcahtoa. Sohcahtoa. The first letter in each of these refers to which ratio it is. So this is sine. The abbreviation for sine is SIN, and sine is opposite over hypotenuse. So the first letter refers to sine. The second two letters refer to the order of the ratio. O stands for opposite, H stands for hypotenuse. The next one is C for cosine, or COS. A, adjacent over hypotenuse. T, tangent, is opposite over adjacent. This is something, again, you're going to want to have memorized, or if I were you, I'd put Sohcahtoa on the top of my notes or a test that I was taking to help me remember the order. This lesson is going to go very similarly to how the last lesson goes. There's three sections. The first section asks you to find the sine and cosine of each acute angle. So let's draw a triangle. 5K, L, M, 24, 18, and 30. I'm going to have four answers because I'm finding two angles for sine and two angles for cosine. Let's start with the acute angle M. I'm going to find the sine of M. Oops, not the sim, the sine. As mentioned above here, sine is the ratio opposite over hypotenuse. So the opposite side is 18 and the hypotenuse is 30. You're always going to reduce. 3/5. Now the cosine of that same angle, so again I'm looking at M, cosine is adjacent over hypotenuse. The leg is adjacent and the hypotenuse is the longest. Still reducing by 6. See if you can find the sine and cosine of the other acute angle. Push pause and try that now. The other acute angle is angle L. So let's start with the sine of L. Sine is opposite over hypotenuse. The opposite side is 24. And the hypotenuse is 30. Reduce. The cosine of L. Cosine is adjacent over hypotenuse, so short leg over hypotenuse. Divide by 6. If you are looking at those 4 fractions and you say to yourself, I notice a pattern, that these are the same and these are the same, that is true for all right angles. In the second section, they're going to ask you to approximate the sine and cosine values to 4 decimal places. So let's find the sine of 18 degrees. You're going to take your calculator and push sine 18. We're rounding to 4 decimal places, so I have 0.3090. The 5th place is going to tell me if I need to round up. Because the 5th place is a 1, this is going to stay the same. If the 5th decimal place was 5 or more, I would round the 4th decimal place up. Try the cosine of 52 degrees. Did you get 0.6157? You had to round up on that one. The last section is actually the learning target. The learning target is to find missing side lengths. Go ahead and draw this triangle right here. We're finding the value of x to the nearest 10th. Okay, so I see they give us this angle right here. This lesson's a little bit trickier than the last lesson because you're going to have to decide if you need to use cosine or sine. You do not get to pick, oh, sine is my favorite. It doesn't work that way. The triangle will tell you which ratio to use. Use my helpful hint. Write down your Sohcahtoa. Look at the angle. They give me this angle right here. And the information is a leg, so adjacent and hypotenuse. Adjacent and hypotenuse is cosine. So I am going to take that adjacent and put it over hypotenuse to set up my equation. I'm going to take cosine of 28, round to those 4 decimal places. Solve this one-step equation. They're dividing, so I'm going to multiply. I didn't even take it out of my calculator. I'm just going to multiply that by 20. And round to the 10th place, 17.7. Make sure you round correctly. Okay, test yourself. Try the last problem. Push pause. Again, I'm going to write down my Sohcahtoa to help me decide if I should use sine or cosine. There will be no tangents on your homework tonight. This is the acute angle they give me. I see they have the hypotenuse and opposite. Opposite and hypotenuse is sine. Opposite over hypotenuse. The sine of 22 is 0.3746. I'm going to solve this one-step equation. And round to the nearest tenth.